We're going to do the sine rule today. Now, sine rule is very easy, right? It's a over sine A equals b over sine b. So essentially, in any triangle where it's right angled or otherwise, the triangle can be any type of triangle really. And what you simply do is this: you pick an angle that you say will represent A. And you go, okay, I'll pick this angle here. And then the side that A looks at has to be small a. Alright? And then you pick another angle to represent B. So let's say that one's B. Then this automatically means that the side that it looks at is small b. So let me follow you in the so because A, B and C are already used, alright, I'm just going to sort of change up the sine rule for you slightly. And here's the sine rule I'm going to use, just so you don't get too bogged down in where the letters go. We'll just call it X, big X, small x, okay? And then we'll call this Y, Y. It's still the sine rule, just different letters, alright? And here's what else we got to do. Right? In the question, it wants this length here. It wants to figure out what C is. Well, C, you're going to be known, X is going to be C. So C. Now what looks at C is the 42. This means angle X will be sine 42. Pick another side that you know. You know 8 meters. What angle looks at the 8 meters? The 57 does. So that's sine 57. And now you're pretty much ready to do this. All you gotta do is say C equals 8 sine 42. The sine 42 is division on the left, makes a multiplication on the right, all over sine 57. Okay, put that all into your calculator, making sure that it's in degree mode, and you should get 6.38 as your answer. And to one decimal place, C will equal 6.4. Is it meters? 6.4 meters, okay? Next one I'll do is I'll do part 3. Okay. Part 3. Once again, I have X over sine X equals Y over sine Y. Now, 70 degrees looks at A, 80 degrees looks at 7. So here's what we can do. A over sine 70 equals 7 over sine 80, and then A on its own, bring the sine 70 up beside the 7 sine 70 all over sine 80. And we get an A value of 6.67 or 6.7. So that is 6.7 6.7 meters, alright? I'm going to do a bit of question 2, because question 2 is slightly different, alright? This time it's angles. So X over sine X equals Y over sine Y. Now once again, you want to know what X is, and it's opposite to 7, so it's going to be 7 over sine X. You know 10, and 80 looks at the 10, so you're going to say 10 over sine 80. Okay. Now, what you're going to do next is you're going to cross multiply. The sine 80 goes from the bottom right to the top left to make 7 sine 80. The sine X goes from bottom left to top right, and then the 10 that was on the top right, that 10 there, well, it should probably go underneath the 7 sine 80 to leave the sine X on its own. So you take out the calculator and you do 7 sine 80, you do that all over 10, and you get this number here. You're going to sine inverse that number. So 0.689 equals sine X. Sine inverse that number to get the angle X. Shift sine inverse answer, or your shift sine inverse 0.698, 689, 43.55. and it wants it to the nearest degree, which would be 44 degrees, right? And that sort of makes sense as well, because if 80 degrees looks at 10, surely a smaller angle would be looking at 7. So 44 degrees makes sense in the context of the question. Alright, next thing, I'm going to do part 3 here as well. Okay, it's the exact same job. X looks at 8, so it's going to be 8 over sine x. And then 51 looks at 9.5. Bring up the sine x, so you get 9.5. And then you get sine x, and that will equal 8 sine 51. Now the 9.5 is multiply on the right, which will make a division on the left. So divided by 9.5. Put all that into the calculator, the usual. 8 sine 51 divided by 9.5, and 0.6544 will do nicely. Sine inverse your answer to get your shift, sine inverse your 0.6544, and you get an answer of 41 degrees. Okay, that's questions 1 and 2 done. Alright, question 3 should be reasonably handy. We're looking for the angle BAC. You can be sine x, and you look at 10. So x over sine x equals y over sine y. So what you can be is, it's going to be 10 over sine x equals 8 over sine 48. Okay, and then once you do that, you can cross multiply up, so you're going to get 8, and you're going to get sine x, and then you're going to get 10 sine 48. The 8 is multiply on the right, which will make a division on the left. Of course it takes the equal sign with it. Anyways, and there you go. Put all that into the calculator once again. 10 sine 48 close bracket divided by 8. And then you can sine inverse the answer. So sine inverse that answer. So you can also say x equals sine inverse answer. And sine inverse answer. Shift sine inverse answer. 68.27 or 68.3. Okay. The next thing it wants is the area of the whole. Next thing it wants is the area of a triangle. Okay, so that's 68.3. Now there's a new rule for this. Okay, and it's known as a half AB sine C. You need any two sides, and you have to have the angle in between them, and the answer would be a half AB sine C, or a half XY sine Z. It doesn't matter, the letters are irrelevant, alright? But here's what we're going to do. We're going to choose 8 to represent A, 10 to represent B, and then angle C, well, we're going to take this away from 180. Oh, I skipped that part. I'll do AB on the next one, lads. Alright, so we can do 180 minus 68.3 minus 48, and you get 63.7. So it's going to be a half AB sine C, which we all know is a half 8 times 10 sine 63.7. and that will be half of 80 is 40, so just 40 sine 63.7. Lo and behold, you get 35.86. Is that okay with you guys? 35.86 degrees. Oh, sorry, not degrees, centimeters squared. Is it centimeters? It doesn't tell us what the units are. It doesn't say if it's meters or centimeters, so it'll say units squared. Okay, now if I actually read the question properly, I have a habit of jumping the gun, I also have to find out what AB is. Let AB be X, and X is opposite that angle I got earlier. What was it? 63.7. So what you could have said was AB looks at sine 63.7, and then pick another angle. 48 and 10, 8 will do me nicely. 8 over sine 48. Somebody else could have chose 10 over sine 68.3. It actually all works out the same. And what we do to get AB on its own is we just transfer the sine 63.7 upwards, divided by the sine 48. And behold, 8 sine 63.7 all over sine 48, and 9.65 or 9.7. Okay, and we already got the area earlier. Alright, let's keep going. 5. Alright, I'll do 2 of these. I'll do 5 part 1, I'll do 5 part 3. Alright, I have xy sine z. X is 8, y is 11. I have 8 times 11. Z is the angle in between, so we'll call that sine A, and that equals 25. Okay, now 8 times 11 is 88, so it's 44 sine A equals 25. Sine A therefore is 25 over 44, and then if you sine inverse that, what you'll get is 34.62. Okay, if we go to part 3, it's a half 13, so x will be 13, y will be 18, so half 13 times 18 sine c, the angle in between, equals 78. Once again, a half 13 by 18, 13 multiplied by 18, half the answer, 117. So 117 sine c equals 78. Oh, once it's in nearest degree, that'll make that 35 degrees. This one here is sine c equals 78 over 117, and c equals shift sine inverse 41.81. C equals 42 degrees. Okay, hopefully that's okay with you guys. Now let's move on. 7. Find RQ. Well, I'll call RQ x, and x looks at the angle 30. So I'll just say x over sine 30 equals root 8 root 8 over sine 45, and x equals root 8 sine 30 over sine 45. Two. X will equal 2, so RQ equals 2. Now, the next thing it wants from us is the angle. It wants us to show that the area is 2.7. Okay, so this area is 2.7. Well, we can figure out what the third angle is, because the two sides we know are, we know this side here and this side here. So we'd like to know the angle in between, so we can use a half xy sine z, or a half ab sine c, whichever way you want to call it is up to you. Now 180 take away 30 take away 45 leaves over 105, so it's going to be equal to a half root 8. Whoop. Intrusive, isn't it? Advertising these days. Sine 105, and then .5 times root 8 times 2 sine 105, 1 plus root 3, otherwise known as 2.7 meters squared. Right, that's 7 done. Let's go to 9. Diagram shows two possible triangles with AB equals 5.4 and angle BAC equals 32 degrees. BC equals 3 centimeters. Find two possible values of angle C correct to one decimal place. Okay, which one's angle C? Oh, I understand. There's two possible triangles, lads. So there's this triangle here. That's one of the triangles. Okay. And then there's another triangle here. Okay. So there are your two possible triangles. I'm going to shrink down this question just to take it out of the way for a second, alright? Just away from my other diagrams. Now, what they're basically saying is that this is 5.4 and this is 32. That's also 32 and that's also 5.4. Okay? And this is angle B, that's angle A, that's C. So this is angle C right here. And if I drag this away a bit more, this is also angle C. Now you can see that one of the C values is bigger than 90 degrees for the top one, and one of the C values is below 90 degrees for the bottom one. Alright? Now it's going to be the same sine rule anyway. Or is it? Yeah, we know that they're 3. So it's going to be 5.4 divided by sine C equals 3 divided by sine 32. Now the issue with this one is we're going to cross multiply up to sine C, so it's going to equal 3 sine C, and the other side is going to be 5.4 sine 32, because the sine 32 goes from bottom right to top left, division into multiplication. Now what's going to happen next is we're going to divide down the 3, and sine is clearly positive here, okay? But what we're forgetting about is ASTC, which we did in the previous exercise. Sine is positive in both the first and the second quadrant. So the whole 180 minus R rule for the second quadrant will also come into play. So we're going to find out what sine C is. So we're going to say 5.4 sine 32 divided by 3. Okay, so answer equals sine C. So the answer I got from that. C equals sine inverse answer. Shift sine inverse answer. 72.52. So 73 degrees. Now, if it equals 73 degrees, that's the answer for the acute angle. But the answer for the obtuse angle is 180 minus 73, which is 107 degrees. Okay, happy days. Let's move on. 10. In the given triangle AD equals DB equals 5, the angle ABC is 43, the angle ACB is 72. Find AB, find CD, and answer each one correct to one decimal place. So, what we're going to do here, I'm starting to feel tired now. I suppose that's to be expected. AD equals DB, 5, 5. Oh, this is an isosceles triangle, which makes that 43. And then 180 minus 43 minus another 43, I believe is 94. Because 94 plus 86 is 180. Yep. So that is 94. Then in a straight angle, it's 180 degrees. So that will make this one, what's it, 86. And then we can figure out what is the angle. Then we can figure out what is the angle up here. This angle here will be 72 plus 186, and we're going to add them together and take it away from 180. It's not much left. Pre-carved here. 180 minus 72 minus 86, 22 degrees. So, what am I actually asked to do? It wants me to find AB. Now, if I'm asked to find AB, I'm going to use the triangle on the right. AB is this length here. So what I'm going to say is AB and looks at the 94. Okay, so AB and the 94 are linked together. Okay, so AB over sine 94 equals 5 over sine 43. AB on its own is 5 sine 94 over sine 43. Which is 7.31. To one decimal place, 7.3 centimeters. C to D, which is this length here, it looks at the angle 22. So what we can do here is C to D over sine 22 equals what is it? Does it equal sine 5 over sine 72? Five sine 22 over sine 72. Okay, gents, so we just put this into our calculator. We get it done. There we go. And that's question 10 done.